Hello and welcome to today's webinar, Achieving the Perfect Golden Record with Graph Data for Identity Resolution. My name is Matt Michelle. I head product marketing at Aerospike. A couple of housekeeping issues. We'll be having Q&A session at the end, but feel free to enter your questions into the system. And the slides will be shared afterwards. So we'll be sharing them after the recording. I'd like to introduce our presenters. With us is Daniel Landsman, Head of North American AdTech, MarTech, and Gaming at Aerospike, where he's led the development and execution of buy-side teams in mobile, video, programmatic media, and data monetization, SaaS, and infrastructure through both partnerships and enterprise sales at Aerospike. So welcome, Daniel.
Thank you, Matt. Great to be here.
Also with us is Anoop Shivadas, Principal Solutions Architect at AWS, based out of Arlington, Virginia, with over 20 years experience in technology. Anoop really takes pleasure in collaborating with AWS enterprise customers to design cloud architectures that are highly scalable, high-performing, resilient, secure, sustainable, and cost-effective. So welcome, Anoop.
Thank you. Great to be here.
And Alexei Rosolovsky, Principal Solutions Architect at Lineate. So he's based out of Brooklyn, New York, and he has over a decade experience in software architecture and engineering, particularly in AdTech. His roles involved in collaborating and defining technical specifications. So he's led engineering teams on both the business goals and the technical requirements to implement scalable AdTech solutions. So welcome, Alexei.
Thank you, Matt. Glad to be here.
So basically, our agenda today is we'll have a brief overview. Daniel will give us a few minutes about that, and Lineate will take us through how they've built a solution integrated with Aerospike. And AWS has their entity resolution solution that Anoop will tell us about. And then Daniel will talk about Aerospike Graph. And so afterwards, we'll have a discussion amongst the three. So with that, Daniel, ready to kind of give us the overview.
Yeah, thanks, Matt. Just want to talk through with everybody to kind of set the table about what the status is of the current ecosystem. So historically, there was, concerns that Google was going to deprecate cookies. However, they did an about face a little bit ago. I think it was a couple of weeks, 3 weeks roughly, and essentially now we are waiting to see what is going to happen and how they're going to implement this opt-in or opt-out to understand what's really going to happen. And a lot of folks in the industry are saying that this could be indicative of similar, deprecation of signal that happened with iOS and Apple. So we need to be aware that we've seen these types of signals go away in the past and understand, some of the results that have happened from those signals going away. And, I've personally been speaking about strategies about how to combat that for, I'd say, over about a year and a half now. And with this recent change in the market, we have to sort of think through, okay, what is going to be the path forward and what steps can we take as organizations and entities in order to effectively maintain our ability to parse signal through noise in an environment where there's going to be greater opaqueness and potentially less deterministic data. So with that, I want to turn it over to Matt and Alexei to kind of talk through where that is, but I just wanted to set the table with that. So thank you.
Thank you, Daniel, for giving a quick market overview. I'll be briefly talking today about Lineate experience with Aerospike Graph database. And in AdTech industry, it's very important to be able to target users, know their intention and interests, and storing user actions, interests, IDs may help you to look up users with similar interests or explore what actions users with conversions has in common, for example, or it can help you to retarget a user or the whole household based on actions or interests. And graph databases can help not only with entity resolution, which is the main topic of our discussion today, but also AdTech companies like DMPs, DSPs, SSPs can find own application in graph database for their use cases. Such databases are also applicable for GDPR-like use cases, like privacy use cases, where you need to show to a user all tracked information if requested, or delete the whole user profile and related data by having just one ID provided by a user. For example, if user gave you his email, then you can delete the whole graph that you have on this user. Similarly, it can be used for fraud detection. If you have a list of bot IPs, you can look up clusters of matched users and then later mark their impressions and clicks as fraud. However, the main use cases and today's topic is identity resolution graph, which is used for ID mapping between partners for targeting and turning anonymous traffic into identified traffic, which has higher floor prices and higher bidders activity. And these days, as Daniel said, like some browsers implementing or planning to implement disabling of third-party cookies by default, or they're planning to ask users if they don't want to be tracked. So losing user action signals is inevitable in the future. So for AdTech players, it means more integrations with data partners, more data sources to work with and join, or implementing techniques like householding. And that's where graph databases come into play. They help to consolidate view from different sources. And Aerospike Graph database is especially interesting in that context because it's known for stable performance, and it's big thanks to classic Aerospike database that use hybrid storage engine. It is very known for many years in AdTech ecosystems. Next slide, please, Matt. Yep, thank you. So let's talk about why Aerospike Graph database is good choice for AdTech use cases. So first of all, AdTech systems are famous for their huge data volumes and the speed with which this data comes into your storages. And there are many graph databases on the market. However, if you intersect their capabilities with AdTech non-functional requirements, there are not many candidates which will be able to handle like latency requirements, data volumes at acceptable level of the cost of ownership. And as I mentioned before, Aerospike Graph database uses Aerospike database's underlying storage engine, which uses RAM only for storing indexes and primary keys, and it uses SSD for storing data itself. And it's also capable to have direct SSD access to the data bypassing file system, which allows to have few milliseconds response time, even for graph lookup queries. So let's take a look at challenges that we face during like trying graph databases and Aerospike specifically. Matt, please, next slide. Yep. So basically, challenges are directly related to, as I mentioned, AdTech data volumes that is often measured in terabytes of data per day and hundreds of thousands incoming signals per second. And since today we're talking about identity resolution use case, so which assumes receiving ID matching signals from multiple partners besides behavioral events data, and such process as cookie matching, for example, especially for desktop traffic, may produce hundreds of thousands of matching signals, and majority of those signals will be duplicates. So if you try to forward such data stream directly to a graph database, it will be very hard to achieve adequate write latency in combination with the cost of the cluster that makes sense. And the same challenge is also applicable for the Aerospike Graph database. It's under the hood, utilizes key value storage to save graph structure. So as a result, it creates multiple indexes to provide you graph lookup capabilities. And you can imagine that even if you insert one edge, the database needs to check that vertices exist. It needs to update indexes. It also needs to insert edge itself to each vertex, or it depends on like internal implementation. And also, if you are using queryable attributes or properties on vertex or edges, it's even more data to insert. So like if you think about records per second metric, like graph records per second doesn't directly map to like a business domain entity. Like for example, if you're inserting two vertices and edge between them, and if those data points have attributes, the database will insert more than 3 records into a system. It has a lot of things to update under the hood. So this kind of challenge that you will face if you try to implement this use case for yourself. So let's now talk about recommendations and ideas, how you can overcome and mitigate that challenge. Thank you, Matt. So you can say that you rely on a database to actually enforce unique constraints on your data. However, since we are talking about identity resolution AdTech use case in conjunction with graph database, it's a little bit too much to expect from a database with complex underlying data structures. So it's highly recommended to clean up your data and remove all duplicates prior to insertion. And I'm not talking here about complete removal of duplicates, which is impossible. But for example, if you work with 5 minutes log files, and then it makes sense to have all unique records inside one file before you insert them. Or if you update your graph database once an hour, then you can implement a cascade of deduplication logic. So you first deduplicate 5 minutes chunks of data, then you union them into an hour file, and then you clean it again and deduplicate, and only then you split it into chunks and insert it into a database. The next recommendation comes from the first one. So basically, don't insert data by one vertex or edge or even by one user profile. Batch your data, you will achieve much higher performance. So Aerospike supports bulk insertion when you supply a database with a file in a Gremlin CSV format, for example, or a batch mode. So currently, bulk file-based insertion works in Aerospike only for initial first-time data migration to the Aerospike Graph database. So for constantly incoming data, it's recommended to split your stream into batches. And the size of a batch is better to find out empirically by running performance tests. Third recommendation is that you can run multiple Aerospike Graph service instances. So as I mentioned before, the architecture of the Aerospike Graph database represents a layer that gives you Graph API and sits on top of key value storage. And in our tests, we saw that actually Graph service consumes more hardware resources than key value storage. So the load that was high for the Graph service was producing pretty low load on the key value layer. So basically on the Aerospike database. So it completely makes sense to run multiple Aerospike Graph service instances, and then you will have to balance your insertion load at the application level. Another idea to try is to not to try to store all users from the whole world in one graph. You can split it into geographical regions, like by continents, for example. And this recommendation will be useful for situations where you already implemented like a multi-tenant architecture, where each cluster has similar tech stack, but it's virtually isolated, and each cluster receives its own independent ad serving traffic. Next item is more like a thought rather than recommendation. So from our experience, the majority of like complicated traffic, I mean with a lot of duplicates, actually comes from third-party cookie matching process. And as we discussed before, that like third-party cookie deprecation is coming, so maybe eventually it will be not even a problem to have like tons of traffic with duplicates. And finally, if your data is still like huge and the cost to store it is beyond acceptable level, like remember that often graph databases are useful not to get a final answer to a data question, but to start exploring your data, start investigations and designing data strategies and prototyping. So like sampling your data often also like a useful step. So now let's see like a real world example, like what the statement means that Aerospike has stable performance. So basically, internally, we did a small test that was ran on very small hardware machines, and it was intentionally to simulate a situation where you have much more data than available RAM in database clusters. So y-axis shows a time in seconds to insert 100K users, so like a set of data. And each point on a graph, it's an iteration of insertion. So how to read this graph is that if you look at, for example, a 2.0 step on the x-axis and intersect it with orange line, then you can read this graph as following, that after 2 million users were inserted, it took about 500 seconds to insert next 100,000 users. So basically, this graph shows that at about 1 million users, like the amount of data was bigger than available RAM in all like 3 clusters. And as you can see, Aerospike continued to have consistent insertion time, but the green line shows that after there was not enough RAM, the insertion speed started to degrade. So next slide, please. Yeah, this slide is just like a supporting slide explaining why you see such Aerospike behavior. So as I mentioned before, Aerospike achieves these capabilities because it's used like hybrid storage engine. It uses SSD drives for data values, and it uses RAM only for primary keys and indexes. So as a conclusion, just to reiterate everything, Matt, please switch to the next slide. So Aerospike Graph database really shines and worth to give it a try if your use case, like if you have a significant amount of data that will have too high cost of ownership if you try to set up some database cluster, which requires memory to feed all data to have predictable and low response time. And if you're already using Aerospike Enterprise in your ecosystem, it gives additional argument to try Aerospike Graph database with your data. So now I want to give a word to Anup to talk more in details about entity resolution and how it can be implemented in AWS. And then Daniel, who will introduce Aerospike Graph database more in depth. Thank you.
Awesome, great, thank you, Alexi. So hi, great to be here. My name is Anup Shivadas, as Matt did the intro. I'm a principal solutions architect, been with AWS for close to 7 years now. Time flies fast. And I work with enterprise customers, on a day-to-day job. Work with multiple enterprise customers in the engineering, construction, real estate, transportation, and logistics space. With that, Matt, next slide, please. Great. So before we jump into the service itself, right, AWS Entity Resolution, just want to kind of level set some of the reasons why we embarked on this journey to kind of build this service, right? So essentially, when we work with customers, and this service was announced during reInvent 2023, which is our event last year. Before that, we've been working on the space for a long time, talking to customers for over 2 years. And some of the themes which we got from customers is data is absolutely siloed, right, across different applications, data stores, and different channels, right? So if I'm interacting with a company, I might be using my email ID, I might be using my social presence, Facebook and other things. I might be using my phone number. So there's different channels which comes into play there, right? And it's often tough to kind of identify a kind of a golden data set, if you will, for a lot of customers. The other concern which we heard from a lot of customers is around data is often incomplete, right? Or it kind of contains conflicting info, right? So that's another concern which we get. And Alexi here talked about duplicate data and whatnot, right? Last but not the least is around security, right? So oftentimes, if you want to, move the data around, it always introduces some security threats, right? So security, data silos, all those things which we heard from customers. That's where we kind of focused on building this entity resolution service, which is all about, helping companies easily match, link, and enhance related records across multiple applications, channels, and data stores. And it's much more flexible to kind of configure the whole workflows, right? Next slide, please. So I want to kind of talk about some of the key benefits, right? So, we've been working with customers, we heard a lot of feedback, and a lot of, customers, including me, have actually tried some approaches around SQL to kind of do some entity resolution in the past and in my previous life. And this can take months or years, if you will, right? If you try to kind of do entity resolution in a kind of a, your own way, manual way, it's kind of really, really challenging. So one of the key benefits of using a service like in AWS Entity Resolution is, you can create these workflows in minutes, right? Rather than focusing on like too many undifferentiated heavy lifting, right? So it's just simple, easy UI-based setup. If you want to do with API or CLI, you can do that as well. But it's super straightforward to create the workflows. And when it comes to the matching side of things, right? You have two options here, essentially, and actually there are three options, but the most important thing is focusing on rule-based matching, and that's one of the key options which we allow customers to do. So there is rule-based matching which we offer. There is also ML-based matching which we offer, right? So we kind of give you pre-configured models which can be used to kind of understand the patterns and relationships and whatnot, and then do this matching, right? So that's the matching side of things. We recently also allowed you to link and enhance your records with data sets that's provided by third-party services, right? Like, LiveRamp comes into play, TransUnion, for example, or Unified ID, for example, right? So if you have, data sets, data service providers data sets, you can kind of connect that seamlessly with AWS Entity Resolution as well. Last but not the least, and I kind of really focus on this as well, security, right? Super important. So we bring the service to the data which you have, right? So we have all the data in S3. Customers will have the data in S3, for example, which is simple storage service, data lakes, right? It's kind of the object store of the world. So you can have this service come to your data, and there's not a lot of movement, right? Data movement which comes into play. So encryption at rest, encryption at transit, right? Using TLS and all those things is available. So we kind of treat security like really, really important, right? So those are some of the key important benefits when it comes to entity resolution. So I want to switch gears and talk about some of the key features as well here. So Matt, next slide, please. Yeah, perfect. So some of the key features here, right? So if you look at your end-to-end data pipeline from input to the output, right? From your data to the golden data set, if you will, right? So if you look at that pipeline, one of the key things which comes into play is data prep, right? It's very important. And since you have, so we kind of deeply integrate with S3 and services like Glue. So we offer you a lot of data preparation capabilities right within the context of AWS, and you can have entity resolution integrate with all the experience like S3 and Glue and other things, right? So making sure your data is really prepped, right? So that's very important. You want to make sure it's normalized. You create schemas around it. So entity resolution service can access the data which is in S3 in the form of a Glue database, if you will. So you crawl the data, you create a schema around it, and entity resolution service can directly access that data right within the context of the service. So that's really, really powerful. The other aspect is around, again, as I mentioned, data protection, right? It's very important. So we bring the service to your data rather than asking you to upload the data in a service or something, right? And we kind of have deep IAM-based identity and access management basis based controls, right? IAM roles, IAM permissions, right? Least privilege, etc. Right? So that's all deeply integrated with the service itself. Then comes the notion of matching, right? So we offer you different ways. One is deterministic rule-based matching. So based on your data set, we kind of give you rules upfront, right? We kind of say like, hey, these are the rules which make sense based on your data set, right? And these rules are very kind of customizable as well, right? If you want to bring some custom rule set, you can actually do that. You can actually move around the rules, right? Based on the priority requirements, you can actually kind of move the rules around. So that's the rule-based matching, right? We kind of give you upfront, like, hey, these are the rules which we think make sense, right, for your data set. The other aspect is around ML-powered matching, right? So that's where we give you a pre-configured ML model, which will actually look for patterns of the data and all those things, relationships and links, and then give you that matching capability, right? So now once you're kind of familiar with the schema, you are familiar with the matching and all, right? Now comes the situation where you will say, like, do you want a kind of manual bulk, or you want to kind of do this automated way, right? As fresh data comes in, how do you want to do the matching, right? So you can do that in kind of bulk, or you can actually do that in an automated way as well, right? So kind of you kind of set all these features. You can kind of have this flexibility. You can set these features, and you pretty much go from it, right? Last but not the least is around like data service provider matching. So things like LiveRamp, TransUnion, and Unified ID, right? So we kind of give you that integrated experience for these providers to kind of have that entity resolution experience in collaboration with them. So that's the key features, if you will, right? Matt, next slide, please. So I was kind of explaining the service itself, right? So this diagram will actually help you understand at a high level, right? So you have all your data record types like customer information, product information, and so forth, right? That data is available. You might have data from other services like CDP, CRM, SaaS applications, and data stores and whatnot, right? So the first aspect is around moving those data to S3, which is the lake, right? The data lake, and Entity Resolution Service will work with S3, and you can use other AWS services like AWS Glue to kind of crawl the data and create a schema and do some normalization, right? So you kind of create a schema, and Entity Resolution will work with that schema specifically, right? And then you pretty much go ahead and kind of use the rule-based matching or the ML-based matching which you want. And you kind of set up the whole matchings pipeline, right? So once that matching is done, once you create that job, it will actually run, and then it'll actually give you the output, right? And that output is going to be available within the lake itself. So you have your, the kind of source data, and then you got the result out of the data, right? After the matching process, right? So once the data is available in S3, you can use services like Athena to kind of really do real-time lookup as well. So if you want to kind of query the data on the fly, right? Using ad hoc SQL, you can do that with a service called as Athena. So that's totally possible. And last leg is around like, hey, once this data is there, right? Once this match data is there, how do you load that to a system like Aerospike, which Alexei mentioned, which is super powerful here with all the capabilities around Graph, right? So again, you can use an integrated service called as Glue to kind of process the data and then load the data, prep the data, load the data to Aerospike as well, right? So that's in a nutshell, kind of a high level flow around how entity resolution works. With that, I want to turn it over to the Aerospike team here.
Thanks, Anoop. Appreciate you sending it over. So we're going to talk a little bit about entity resolution with graphs and how identity is going to be at the center of the ecosystem moving forward. So earlier in the conversation, I had mentioned that with respect to cookie deprecation, we're trying to wait to see how Google is actually going to implement that. But today, 47% of the open internet is unaddressable because of cookie deprecation already. And it could rise to over 90%. And there has to be a plan in place about how to effectively target audiences at scale. This has implications with things, on the bidding side, if you're a DSP. This has implications on the attribution side, if you're an MMP or some other type of measurement provider. And there is a need to understand, is the spend that the advertisers are putting forth into the ecosystem generating ROI? And without a good way to understand, whether it be media mix modeling or some other types of tools that are able to be used in the ecosystem, there needs to be some type of backbone and underlying structure to support this, right? And the joining of AWS Entity Resolution with Aerospike Graph, you can work with a service provider like Lineate to help install it, is really what I believe every company in the ecosystem needs as the ecosystem continues to move forward. And we see a lot of our clients, as Alexei mentioned, who already use Aerospike Key Value, gravitate towards our Graph service because of the flexibility that it offers and the capability to actually continue to add more data in a manner that falls in line with your business objectives. I actually was having a conversation with a client the other day, and they were telling me that they're exploring adding multiple different identifiers to their bid stream, like ramp ID, like UID, but each incremental identifier that they're adding is allowing them to monetize what would historically be blind traffic. For those of you on the call that don't know what blind traffic is, that means there's no signal associated with it. So anytime you can attach a signal to an impression in the open internet, it is going to monetize much more effectively. And how all these companies monetize is they all make money when the money is spent. So it has to be that there needs to be some type of way to layer on signals, and the combination of AWS Entity Resolution with Aerospike Graph empowers companies to decision against that data at scale with our core tenants, right? Next slide, please, Matt. So with our core tenants, what I mean when I say that is our high throughput, low latency at massive scale. When we were building our graph service, we wanted to actually enable companies that know the historical performance about who we are and what we do to be maintained at scale in graphs and entity resolution. As Anu mentioned, it's relatively complex, and same thing with Alexi, you had to do a lot of deduplication. And within the AdTech ecosystem specifically, you have to be able to operationalize that data in sub-millisecond latency. Buy side, you have very short time to respond to an auction. Sell side, you have to convert that information to a request out to your respective partners. If you're a data vendor, you have to syndicate that data to where it needs to be very quickly. But then additionally, we work with a lot of platforms that are doing fraud detection because there's so much invalid traffic in the ecosystem that it's important to mitigate that in the supply chain as much as possible. There's been a lot of steps taken and the ecosystem has gotten a lot better, but there is still the capability to continue to layer on more advanced fraud protection and do that through graphs. I mean, we have multiple clients that publicly disclosed they built graphs on top of Aerospike. Adobe's built one, PayPal's built one, and we have a historical precedent set with all of these companies that were capable of achieving the scale objectives and the latency objectives within the acceptable range of total cost of ownership. Next slide, please. So with that, what are the limitations of existing graph databases? So they're not built for real time. They're cost prohibitive. They're hard to scale beyond a certain point. I've heard stories that, some of the competitive set that we have, is not really as scalable as Aerospike above, let's call it the 5 terabyte mark. And, things get unpredictable as the volume of data and the transactions continue to grow. So they're costly to implement, and it creates technical debt. I would also say that they aren't pulling data from the same system. Aerospike Graph actually is a service that we built on top of the key values for a database that leverages our hybrid memory architecture and possibly our all-flash, as Alexi tested as well, that enables companies to continue to scale. Next slide, please, Matt. So this is a architectural overview of what it looks like. So underneath the hood, you have the Aerospike database, and that is, the key value store where we're storing the indexes. On top of that, we built a compute engine with Tinkerpop so that you could run the graph service. And that's where you're going to be leveraging the Aerospike system and being able to do those traversals for your edges and figure out where your data is with multiple different hops if needed, and layer on multiple different types of queries depending upon what it is that you need to understand about your data. Next slide, please. So here's where I want to talk through what does a rough graph identity structure look like. We broke this out into two parts, and as we're going towards a golden record, you have sources, and then you have those connections, which are the edges and the vertices that you're going to traverse to understand whether or not is this a household. So we have clients that are matching multiple different sources from multiple different vendors and layering on all those different types of signals to create golden records. They can understand more holistically, is Daniel Daniel, is Anoop Anoop, is Alexi Alexi, is Matt Matt. And the way that they're doing this is some of those signals might have IP, might have an email address, whereas some of those signals might have an IP address and device ID, as well as some type of firmographic or psychographic data. And when you can join all of those together, you can get a much better picture and understand who said individual is, whether you're doing customer 360 or audience targeting. It's applicable to multiple industries. I'm aware of some of our fintech clients that are leveraging this to just understand, who's accessing their system. There is a multitude of types of use cases, but I believe that if you're able to more effectively understand who said individual is with this type of graph architecture and model, you're better able to serve them and give them the most viable customer experience, whatever the ecosystem that you live in may be. So next slide, please. So with that, why Aerospike Graph? You could have trillions of edges and vertices. It's enterprise ready. We have a low TCO, which falls in line with our core tenets. We can deal with low latency, multi-hop queries with single-digit millisecond. We can do mixed workload handling, and OLAP is now coming out in the next few weeks. So we're really excited about that. That's going to give you the capability to explore that data like Alexi was talking about a little bit more, but additionally still maintain that high throughput. So we're here to help you and support. We appreciate the time. Matt, next slide, please. Thank you.
All right. Well, thank you, everyone. This is a great conversation each of you had. I'd like to kind of bring it together, synthesize with a discussion. If people want to find out more information on each of the companies and what they have to offer, I'll kind of leave this slide as we get started here with a couple of questions. One thing that I heard in spades, maybe one of the key words outside of the word graph itself is just deduplication. And so this seems to just be part of the nature of running a graph solution. So I'm not sure I'm not sure which of you I would direct this question to. Anoop, I'm not sure if that's part of AWS's Entity Resolution solution. Maybe Glue does it, but in any of your experiences, are there certain techniques to deduplication? Because I imagine things, entities might be imprecise. First name, Matt and Matthew and Matt Bichelle and Matthew Bichelle. How do you determine, that that's a singular entity? Is there NLP put in place? What techniques have each of you experienced with that?
So I can, yeah, AWS Entity Resolution does support data deduplicate related records, right? To essentially better analyze information, and even that is very important to kind of for model training as well, right? So we have customers who are actually using Entity Resolution to kind of remove duplicate records, kind of deduplicate related records, and use that data for model training as well, right? So absolutely, the service does support deduplication as well, absolutely. And behind the scenes, I'm not able to kind of talk through the details of the models and whatnot, but the models are very powerful to kind of help you deduplicate data.
Perfect. So Alexi, you had mentioned that one of the challenges is indeed data deduplication. Can you elaborate, why there are so many duplicates, and can you maybe even quantify how big the problem might be?
Yep. So when I mentioned duplicates, yeah, I specifically meant cookie matching process. So not like the data quality example that you just mentioned, that people, for example, entering their names differently, and then you do need to do different heuristics to match, like I don't know, phonetic matches or machine learning matches. So I was talking about cookie matching process. Is basically the way how it works is that there are cookie matching pixels on websites, and every time user visits a page, the page may initiate cookie matching process between AdTech partners. And if, for example, if the same visitor of a web page visits multiple pages of the same website or even multiple websites, like his particular cookie matching signals comes multiple times every time, or not every time, but multiple times in an hour while he's browsing internet. And the same ID matching pair, like between partner A and partner B, may come into the system many times during an hour. And from our experience, for example, we saw log files, like for example, 2 weeks of log files consist more than 80% of duplicates. And if you take like 30 days of logs, then more than 90% of data actually will be non-unique pairs. So that's like a really significant amount of data. So it means that useful data is only like 10%, and all the rest need to be cleaned out before inserting to a database.
Noise, yeah, certainly. In Daniel, with Aerospike or just overall other limitations on data types for deduplication in inputting that data into graphs?
Yeah, I'm not going to speak to that so much, Matt, but I think it goes back to the old adage, garbage in, garbage out, right? You need to have clean data going in to get a good result out. But I think that these guys did a great job of speaking to, how to clean that data. There's a lot of flexibility with, Aerospike database, and you can find all that information on our docs page.
No worries. One of the things, I think Daniel talked about, I think each of you talked a little bit about it, is maybe at least a pause in the deprecation of cookies in industry. Google's announcement, they're not taking them away maybe as quickly as we might have thought, if at all. And I'm curious, if cookies are deprecated versus if they're not, how does that affect graph data modeling, graph data solutions?
I'll take that real quick. So, my personal opinion about this is that there's, a lot of good that is going to come from Chrome not deprecating cookies right now. And the reason for that is because you still have a deterministic signal, and it gives you a longer runway to have a better plan. So realistically, if cookies were just going to go away, there may be cases where companies weren't fully prepared. And now this has been delayed and kicked down the road multiple times. So you could argue that this has already happened. But this particular instance, I think, has come about because there was an industry analysis that was done with respect to where the gaps were with things like Privacy Sandbox. And there was a very large document produced. I think that overall it sets up the industry to better have solutions around making sure that there's still ability to target while the signal exists, but have a smoother off ramp from cookies, so to speak, right?
Makes sense. Anything to add, Anoop or Alexi? I see some heads nodding. Maybe others can't see, but
No, I agree. Yeah, thank you.
All right. Maybe not the last time we'll have agreements, which is good. So Anoop, so let's stay with you maybe. So it's a little unclear on how AWS Entity Resolution and Aerospike Graph work together.
Yeah.
Can you describe this a little bit more, maybe?
Yeah, absolutely. So essentially, like I mentioned, right, Entity resolution will allow you to connect all of the data you want together, right? And you have two ways of doing that. One is rule-based matching and ML-based matching, right? So rule-based matching, we give you a lot of recommendations on rules, which we feel is making sense for your data, and then we give you that flexibility, saying that, hey, these are the rules which you can use to kind of match the data, right? If you are not really comfortable with rule-based matching, if you want, again, more powerful way of kind of matching, then you will pivot to the ML-based matching, right? So once all these matching is done, then you can get that data, right? So the matched data can be put into Aerospike, right? So we discussed about a brief architecture around using Glue to kind of prep the data and then make it available for Aerospike, right? So once the data is available in Aerospike, you can essentially use it for your decision making, right? So the operational side of things around decision making, Daniel spoke about that a lot, right? The ways of finding different personas within the same household, things like that, right? So all the operation side of things, decision making side of things can be done on the Aerospike side, right? So that's how we kind of frame this relationship between entity resolution and a graph, strong database like Aerospike.
Okay. One of the things you mentioned was about the data model and working on it as part of the AWS Entity Resolution solution. But the other side could be like, if cookies are staying and you want to incorporate them into a graph, could you also have the flexibility to not redo your whole data model? And so I'm curious, Daniel, if people didn't necessarily want to do that, is there a way that Aerospike could help them with that?
I mean, I think that the question is do you want to leverage graph capabilities or not? Like, I literally had a conversation with a potential client the other day, and they're running multiple different key value stores and stitching them all together to act like a graph, even though they still have cookies to this day. Right now, it's kind of a binary question, in my opinion. It's like, do you want to do this or not? I would say that the question that, if I'm on the other side, I would ask myself, hey, do I want to have ease of use with my data model and more flexibility, and possibly, bring down my overall cost structure? If the answer is yes, then you should probably look at graph. Like, that's really what it comes down to. There's always a way to sort of build around things, so to speak. But I think the reason that we built this graph service was because we started to see companies were doing this type of thing already on top of Aerospike, and we saw a need and a demand for it, right? So hopefully that helps answer the question. But I think it goes back to what I said originally. It's do you want to keep things as is? If so, great. If you want to continue to evolve and have more flexibility and be able to do more unique and interesting things with your data model and add data sources more simplistically, then absolutely move towards graph, right? Anoop,
Yeah,
I think you have something to say.
I think scale also is important, right? Most of the time scale is also very important, because if you are dealing with large amount of connected data, definitely look at graph.
Yeah, there's an inherent power behind the graph data model. It's interesting, Daniel, talking about Aerospike, it's been in market over a year, and but there have been existing solutions. I think, Alexi, there was something a little surprising that you were showing the was it the batch ingest of Aerospike versus Neptune, an existing solution, and Neptune seemed to increase after a certain point. Aerospike stayed relatively flat. In your words, is there a reason for that phenomenon or that behavior for ingest?
Yep, and I was talking about this, like Aerospike achieves this kind of stable performance because it doesn't directly rely on RAM to achieve a quick like insertion and like data retrieval response times. So it uses like its own proprietary solution to have direct access to SSD, like block storages. So it bypasses file system to access the data. So it gives additional boost like for the timings, and RAM in hybrid storage engine is used only for indexes and primary keys. And actually, Aerospike has all hybrid storage engine, which is available only in enterprise license. But that storage engine is also interesting because it's completely independent from RAM. So in this mode, Aerospike completely stores everything on SSD drives. So it's like even has lower cost of ownership if you have like really huge amounts of data, because like with like classic and default hybrid mode, you still need to be careful with capacity planning because all primary keys and indexes still need to fit the memory. But with all hybrid mode, like you have more flexibility.
Well, I think that's speaking to the point that Anoop just brought up. He said scale is a factor that you'd want this type of solution for. So I think that describes both that phenomenon and the ability to scale. On the topic of existing solutions, maybe versus say Aerospike, Daniel, you had mentioned that there were cost challenges to other solutions. Is there something kind of underpinning that, and to your knowledge, that hey, these things maybe they have limitations, as Alexei showed with batch ingest at certain scale? What is it about the cost aspect of other solutions?
Yeah, I mean, I think it goes to the same thing that we see with some of the key value stores. As the solutions start to scale, you need to continue to put more hardware at it. It potentially could become exponentially more expensive to maintain the performance requirements of the system. And that's where Aerospike continues to scale effectively from a cost perspective.
Okay. All right. Well, look, I think that I'll really pause there and really just thank each of you for presenting. I think there's a lot of material you covered, and so I really want to thank each of our presenters and thank everyone that did dial into today's webinar. Really appreciate it. We look forward to hearing from you. So thanks again, everyone.
Thank you,
Thanks,
Matt.
everybody.
Thank you.
Bye.